Here we are with linear regression, a review topic that we covered at the beginning of pre-calc. So first, linear regression can be best modeled with a line that passes through as many data points as possible, balances the remaining points above or below the line. The equation for linear data should be in slope-intercept form, y equals mx plus b, or you could use point-slope form, which is y minus y1 equals m times x minus x1. So I'm going to do an example problem for you here. Find a linear equation to approximate the following set of data points. Show all of your work clearly. So the first thing you want to do when you're solving a problem like this is you want to plot the points. So let's go ahead and start by doing that. And once you have the points plotted, what you want to try to do is draw a line that's going to fit the data set as best as possible. Again, this isn't 100% accurate when we're doing it by hand. You can always use your TI-83 and plug the points in and use the linear regression function of the calculator to get the exact answer. But you will be required to be able to do this by hand. So if we go ahead and draw that line here, again, it's going to be a rough estimate. You want to go through some points, try to balance the others. It looks to me like something like that would be okay. Of course, you could always drag this a little lower. Maybe make this a little higher. You got 3 above, 3 below there. 2 above, 3 below. Okay. And then, you kind of come up with what you want and what looks good. Then the second piece of this is to write the equation of the line. So this says find a linear equation. So that's the actual directions there, the linear equation. Again, that's y equals mx plus b. Okay, or remember m is the growth, b is the y-intercept, or if you don't know those, especially the y-intercept, point-slope form is a great method. Now for this particular problem, the way I drew my line of best fit, the y-intercept is very obvious, it's 2. And then if I wanted to find the slope, if I have 2 data points that my line goes through, I'd like to use those 2. But if I don't, I can always use any 2 points that my line goes through to draw a slope triangle. So if I do that with these points here, okay, I would have up 5 over 5. That's easy. So my rise over run ends up being 5 over 5, which is 1. My y-intercept happens at 2. So if I was writing the equation of this line on a test, say, I would have y equals 1x plus 2. Of course, like I said, the alternative would be to use point-slope form if you don't know the y-intercept, if it's not obvious in what you're doing. So let's just say, for instance, I was using these 2 points here. I would go up 3 over 3, so my slope works out to be the same. And then I choose a point, say this one, that my line's passing through, which is 3, 5. And I write my equation y minus 5 equals 1 times x minus 3. And that would be the point-slope form of the same equation. And that's linear regression.